So a homogeneous function of degree p. Homogeneous function of degree p have a current function now. It is a function which has this property f lambda x1 lambda x2 and so on lambda xn. This is equal to lambda to the power p multiplying on f of x1 x2 and so on till xn. If a function satisfies this property, then this function is called a homogeneous function of degree p. Example example suppose let us consider this function f of x y z. This is equal to x square z plus y z square plus x y z. See function z. Let us check whether this function is a homogeneous function or not. So what do? Say that we calculate f of lambda times x, lambda times y, lambda times z. Instead of x, we should write lambda x whole square. Instead of z, we should write lambda z. Plus, instead of y, we should write lambda y. Instead of z, we should write lambda z whole square. Plus lambda x, lambda y, lambda z. Plus lambda x, lambda y, lambda z. Now lambda is some parameter ka. This will give you lambda square x square times lambda z. So this will give you lambda cube x z. Plus lambda lambda square. This will again give you lambda cube y z. Lambda lambda. So multiplying lambda 3 times, you will get lambda cube x y z. Now I can take lambda cube common from this. So lambda cube xz plus yz plus xyz. Now this term inside the bracket, it is equal to what? F of xyz. So this is equal to lambda cube f of x y z. Okay. So from this expression, what do we see? We see that the given function is a homogeneous function of degree 3. So from this property, we can see that the given function is a homogeneous function of degree 3. So this is what we mean by a homogeneous function. Euler's theorem. What does Euler's theorem say? What does Euler's theorem say? So let me share the screen again. Euler's theorem annotation. Okay. So what does Euler's theorem say? Euler's theorem here only undo. Okay. Euler's theorem says that if f is a function, a homogeneous function of degree p, then x times del f by del x plus y times del f by del y is equal to p times f. X times del f by del x plus y times del f by del y is equal to p times this. Okay, let us stop sharing. Let us see what Euler's theorem says. Euler's theorem. Euler's theorem na kari haige haibada if f is a homogeneous function of degree p. Say f is x ko y function here. Say this is lambda to the power p f of x comma y. Then see already p times f of x comma y. This is equal to x times del f by del x plus y times del f by del y. Sigma nahi hai wo. Let us consider one example. Wait, example I will discuss the proof the like proof the it is quite simple. So I leave the proof to you. Let us consider instead one example. Suppose f is given by x y sine z plus x cube y e to the power minus omega square w square hai ko do regadi sigi seida sigi function ji mun ne ngo sigi function ji da independent variable mari yawe x haiba ama y haiba ama z haiba ama w haiba ama. There are 4 independent variables, but independent variable loinamak to homogeneous hoidabasu yai ko segi seida akoina homogeneous function je say sigi seida this is a homogeneous function of 2 independent variables x and y. Aduga w ga z ka je suppress toba yae ko yengse ko. Say this is suppose f of so lambda x lambda y. So this is equal to lambda x times lambda y. Atai koi di lengna thamaba sin z plus lambda x whole cube by lambda y e to the power minus w square. So this is equal to lambda square xy sin z plus lambda cube divided by lambda, so lambda square x cube by y e to the power minus omega square. Aduna segi lambda square common log tho ai kari phange xy sin z plus x cube by y e to the power minus w square. Now this expression is equal to the expression of the given function. From this we can say that this is f of lambda x lambda y is equal to lambda square times f of x and y. So this given function is homogeneous of degree 2 in the independent variables x and y. I variable atopa z ka w ko suppress or tham khabo suppress tokre aduga sekari hare this function is a homogeneous function of degree 2 in the independent variables x and y. Let us see whether this given function satisfies the Euler's theorem or not. So first let us calculate del f by del x. Del f by del x. What is f? F is given by this expression. So if I differentiate this with respect to x, what y constant x we get y times sin z. And then we have plus, so the x cube later, so we'll get 3 x square by y e to the power minus w square. So this is del f by del x, and then let us calculate del f by del y. Del f by del y what is the we get x sine z, x times sine z. So if you differentiate this with respect to y, what do you get? Minus y square. So minus x cubed by y square e to the power minus w square. So this is del f by del x, this is del f by del y. Euler's theorem satisfied what do we do? Euler's theorem satisfied del f by del x that we multiply by x, del f by del y that we multiply by y, and we check whether it is equal to p times f of x and y. For this given example, p is equal to 2. So let us multiply del f by del x, this term by x, this term by y, and add them. So x times del f by del x plus y times del f by del y. This should be equal to, from this we get xy sine z plus 3x cubed by y e to the power minus w square. Plus xy sine z minus x cubed by y, y multiplied to y square, y e to the power minus w square. Now this two are the same, so we get twice xy sine z. Now this is 3x cubed by y, this is minus x cubed by y e to the power minus w square. So 3 minus 1 is 2 plus 2 times x cubed by y e to the power minus w square. So from this we can take 2 common and we get xy sine z plus x cubed by y e to the power minus w square. And this expression is the same as this expression, the given function. So this is nothing but 2 times. Oh, this is 2 times the given function, 2 times f. So from this we see that the given function satisfies Euler's theorem. X fx plus y del f by del y should be p times f, where p is 2. So from this expression we see that the given function satisfies Euler's theorem. I think that's all for today. We can stop here.